Hello friends, today I'm back with new solution to this Leetcode problem. So this is to find longest common prefix. So here we are given two arrays with positive integer values and we need to find the longest common prefix. So what is actually a prefix? Let's take this example. So if we have a number, let's say 1 2 3 4, then this number has prefixes. So basically prefix is starting from the very first, which is leftmost, we take all the integers, we take all the digits, and then it's consecutive digits also. So we take the digit 1, and then starting from first we take its consecutive 1 2 1 2 3 1 2 3 4. So these are the prefixes for this integer. Okay, now we know what are the prefix for this integer. Now we need to find longest common prefix. So for that, to find a common, we need at least two values, right? So now let's take these two integers. So what would be the longest common prefix for these two integers? Basically that would be 1 2 3, because 1 2 3 and 1 2 3 matches both the integers prefix, right? So that is the longest common prefix. But here we are given two different arrays and we need to find that between two different arrays. So let's take another list. So this is list array 1, then we would have array 2, something like this. Okay, so this is our array 1 and this is our array 2. Now we need to find the longest common prefix between these two arrays, which means that we are comparing each of the integer numbers in this array with each of the numbers in this array to find the longest prefix. So between these two we have the length only 2, right? Because the first digit matches the first digit, and then again the second digit also matches the second digit. So far the first two digit is matching. Now what about the third digit? It's not a match, right? So the length is 2. Now we compare this with this one again. So we compare each of the digits starting from first, and then we see that all of these digits match. So the length so far we found is 4. Similarly we do the comparison with this one as well. Okay, and this with this as well. Okay, so finally we come up with a result of 4. Okay, but let's suppose that if we had one more value here, one more integer here. So in that case, now we will need to compare this with both of these values, right? So what we are doing, we are comparing each of these integers with each of these, right? We are comparing these with both of these, this with both of these, this with both of these. So basically if this is of length n and if this is of length m, then our time complexity would be O of n times m. And not just that, we are comparing each of the digits, right? We take the first digit, compare it with the first digit, then we move on to the second and comparing with the second, and so on. So since we are also comparing each of the digit, and if the digit is of length, let's suppose length k, then that would be times k starting from each of the first digits. Okay, so let's take this to the drawing board. Alright, so we have array 1 and array 2, and let me just draw this. So now, okay, so we are comparing first digit with the first one, and again we are comparing second with the second digit. Okay, so basically what we are doing is, we have, if we create a tree of the first integer 1 2 3 4, then when comparing this with the first integer, what we do is we compare the first digit, right? So we are taking the first digit and we see that that is a match. So we move on to the next digit, we compare with our next digit, right, which is 2, which is again a match. Now next is 2 again. Now this is not a match for us, so we stop right there and we see that our longest length is 2. Now we do the same for this as well, right? Okay, so we have 1 2 3. So instead of creating another tree, we just use the same tree. Okay, so we use the same tree and we mark its end with some value. So I'm marking it with an X. We can mark it with any other values. So we have 1 2 3 4, we have 1 2 3. Okay, and similarly I will do this one as well. We have 1 2 3 4 and 5. So this will have another branch going to 5, and that will mark our end. Okay, now when we do our comparison, so we take this first integer and we start comparing. So we compare the first letter digit, which is 1, we move on to the second, which is 2, then we move on to the third. Now the third letter digit here is 2, but we found a 3, so we end right there and our length was equals to 2. Now moving on to the next integer again. So what we do is we compare the first digit, okay, 1, we compare the second, which is a match, third, which is also a match, and fourth, which is again also a match. Now we ended the length, right? So the length here was equals to 4. So basically this helped us minimize our time complexity. How? So first we create this tree, which is basically called a trie. Okay, so we are going over each of the integers and each of the digits in that integer to create this one, right? So we take the first integer and then we go through each of the digit and create a tree. So our time complexity here is of n times the digits. Okay, let's suppose that is a value k. So these are time complexity to create a trie. Next, to search in the trie. So what we do is we take each of the integers and we go over each of the digits again, right? So that is O of m plus k, m times k, right? So our time complexity would be big O of n times k plus m times of k. So this becomes our time complexity. So we reduced our time complexity from n times m times k to this, which is a huge reduction in time complexity. So what we need to do is we need to first build our trie. Okay, so to build our trie, we need a root node, and starting from that root node we are going to add the digits at each of the first digits. So let me create a new function for creating a trie, and here we are going to take an array and let us define our root. So now this root is our set. This root will contain will be pointing to the first digit of all the integers in this array. Okay, so we start from each of the number in the array. So starting from each of the number in the array, and we need a pointer to the root. So starting from root pointer over each of the digits in the loop, in the number. Okay, so what we can do is let d of num dot, so we are converting this to a string to perform our comparisons for each of the digits. Okay, and what we try to look for is if we have the digit in our hash map already. in our try. So if we do not find that, then we are going to create a new set, create a new dictionary of this, and what we next do is we move our pointer to pointer of that digit, the end, right? So the end will be marked once we have exited out of this loop, that is we have looped over each of the digits. So now pointer of end, so we can define something like that, or we can define anything that would define the end, is equals to pointer of any values. Okay, so I am pointing to a number. Now here we need our max length, right? So let us define it as 0 because we'll be calculating that. And now let us find our try. So build, we are calling the build try function. Okay, and pass our array, first array, because we only want to build the try for that one. Now for our next array, we will be looping over each of its value, each of its integer. So we need to calculate the length of the substring, right? So first length will be equals to 0. Now starting from each of the digits in that array, so if we found a match in the try, but before that we need a pointer. So pointer will be pointing to root at the beginning of each comparison, right? So now if pointer d is present, then what we do is we need to increase our length because we found our substring, right? Else we increase the length, and we also need to do one more thing, and that is to go back to increase our pointer to go to the next digits, right? Next value. So we move our pointer. Now we have the length and we have the pointer. So after we have traversed over each of those, now if it doesn't find, then we are going to break because we did not find that string, right? So we just break out of that loop because there is no more matching prefix. So now our max length, we are going to calculate our max length once we are done looping over these digits, and our max length will be the max of max length comma the length we found from comparing the digits here. And finally we are going to return our max length. Okay, now let us try to run this code and check. Okay, try that we build. So these are some of the small mistakes that we do. Okay, so test case is passed. Let's submit this code. Alright, so I was able to get 257 milliseconds, which beats 74% of other codes. So this is pretty good code. So yeah, this is using a try method. So there is another method using subsets as well. So I have done that solution here. You can go through this solution, and yeah, this is a pretty easy solution. So I hope you will not have any problem with this one. So I hope you enjoyed this and learned something from this. Let me know in the comments down below. Thank you.